I want to start out giving you a little bit of ammunition that you can use when you're explaining to someone why they should be concerned with embodied carbon in buildings. So supposing you want to reduce your own carbon footprint, what action could you take that would be most effective? And I put a couple of choices here. Avoiding intercontinental flight, changing your diet to eliminate meat and dairy and alcohol, deciding that you're not going to drive anymore, or limit yourself to public transportation, or if you're an architect, an engineer, or designer of some sort, reducing the carbon footprint of the buildings that you work on by 1%. And it turns out that as designers, as manufacturers, as engineers, the carbon footprint of the work that we create is much larger than any of the things that we do personally. I chose that 1% number based just on what Alexandra said a moment ago, that the carbon footprint of the lighting in our buildings is probably on the order of magnitude of about 1% of the entire carbon footprint of a building. But that's the equivalent of 6 people giving up their Big Macs for a year. So at Arup, we decided that we needed to go along with the Paris Climate Agreement, with the Architecture 2030 Challenge, and that we would make a number of, we would take a number of steps to reduce our own company's carbon footprint. We would reduce our purchasing, our catering. We made a commitment back in 2018 that we would reduce our transportation emissions by 20% by creating a flexible workspace where people could work from home 1 day a week. I'm happy to say now that we've exceeded that. And all of these work together to help us to reduce our company's carbon emission. But we also realized that compared to the carbon that goes into the buildings and structures that we produce, their own offices only account for a very small portion of that. So our reach is really a matter of our influence on our clients, of how we can help them to reduce the carbon footprint, the global warming potential of their own projects. And so that's really what I want to focus on. And to help us, we created this tool, we call it Zero. Externally, we call it Arup Zero to avoid confusion with other companies' own projects like Coke Zero. But the idea is that we create a couple of databases. So we curate data that we get on the carbon intensity of different items. We take in weather data so we can look at building energy performance and so on. And we also collect data from our past projects, which helps us to create benchmarks. And this is something that we're now working on extending to all of the projects that we work on, so that every building that we get involved with, we will do a life cycle carbon assessment for. And so I want to sort of illustrate, what does that mean? What is the carbon footprint of a building? So let's say that we're planning a building now. It's going to be constructed in 2025, expected lifespan of 100 years. And there's a certain amount of carbon equivalent, measuring it here in tons of carbon dioxide equivalent, that goes into the construction, the mining of materials, transportation to the site, erection on the site, and so on. And that's the embodied carbon of the building. In addition to that, there is the operational carbon. There's the amount of energy that we're using in the day-to-day operations of that building throughout its lifetime. And that accounts for about half of the total carbon footprint of the building. And if that's about half, then there must be something missing here. And what's missing are retrofits. So let's say every 20 years we're going to go in and we're going to rip a bunch of things out and put some other things in. And each of those is going to have some additional carbon emissions associated with the extraction of material, landfilling of material, and production of the new material that's going to take its place. So now we have the building's carbon footprint, and we want to find a pathway to zero. We want to find a way to reduce that so it goes back down to the x-axis. And so our first step is going to be to say, well, can we reduce the carbon footprint of construction? Can we reduce the amount of embodied carbon and just bring the whole thing down? Then we'll also try to reduce the embodied carbon in each of those retrofits that took place. And finally, we're going to try to find more efficient systems to put in the building. So each of these is helping to bring that down. And then what's left, we want to handle through renewables, through carbon offsets, in order to reach net zero. So we have a zero carbon building. And this is a hypothetical building here. The lighting would take up about 1% of the total there, but the shape of the curve for lighting would be similar to the shape of the curve for the entire building. And so what can we do to create circular lighting? What can we do to create net zero lighting? The first thing, and I actually call it the zero width principle here because it's before we even start thinking about electric light, is how can we bring in daylight? Because if we can bring in useful, effective daylight, then we can reduce the need for consuming energy for electric lighting in the first place. That just helps us lower our carbon footprint altogether. Once we've identified what lighting that we need, then we come to these other four principles. First of all, a circle of lighting materials. So making sure that we're using products that can be upcycled or downcycled at the end of use, or as a last resort, recycled, used in some other way outside of their lifetime as a lighting product. Trying to use adaptable systems that can be changed to meet future needs, that can integrate with other parts, even potentially parts that haven't been invented yet. And providing flexibility, which flexibility in this case means the ability to take the same lighting products and use them for multiple purposes, to take this room from a day look to an evening look and so on. And finally, high quality design. Why do we worry about high quality design? Because if we can create lighting that people like, then they're not going to be in such a hurry to replace it. So we had a few rules of thumb then for how we would create this carbon effective lighting. So the first thing is transition to LEDs. Why LEDs? The graphic here comes from a Department of Energy study. It compares the resource footprint of a number of different axes here between incandescent lights, compact fluorescent lights, and then a few generations of LED lighting. So the incandescent lights are represented by the blue outer ring, which is the highest footprint, and then the others are shown relative to that. And the point was to show that as LEDs are improving, their total impact on our resources is becoming much less than the impact of these other lighting technologies. So we have gone to using all LED lighting in all of our projects. The next question is, well, how do you select a fixture? One thing I want to point out is that if you're working with linear fixtures, you have fewer fixtures, less packaging, less transport. You reduce the carbon footprint from the beginning. And so we tend to prefer going with the linear fixture model as opposed to going with a bunch of spot fixtures. Then where do we source it from? So for a project in Boston, am I bringing in my lighting, am I shipping it from somewhere nearby, in Montreal maybe? Is it coming across the continent from Seattle, or am I using overseas shipping from China? Depending on how far it's coming, that's also going to contribute to the carbon footprint. And finally, Alexandra mentioned that question of the EPD. So do we have an EPD? And we use a form very similar to the graphic that Alexandra showed, where we can just record what information are we getting from the EPD. Do we have each piece of information? So there's an X if we know that information. If we don't, it says module not declared. We don't know. Right now, we're just working on the basis of looking at industry averages, trying to guess what the carbon footprint is, but we're trying to build out that database again. So we're trying to come up with more accurate pictures of what is the actual carbon footprint of each product that we're putting into the building. So here's an example. This is the Amora Pacific headquarters. It's located in Taiwan, I believe. And it's a project that we are highlighting as a use case of low carbon footprint lighting. So what did we do? First of all, we developed our own luminaire system for this building. So it's actually produced by Via Bizuno. It is a modular fixture, so there are a few different lighting distributions and combinations of lighting elements that can go into it, and all of the components that can go into it are replaceable. There's a glamour shot of it there. You can see one of the optic elements on it, and then here a different optic element, so a different lighting distribution that comes out of the system. But to show that it meets our core principles of circular lighting, first of all, even before we thought about what the electric lighting is, we were doing daylight analysis of the space. And it's designed architecturally to allow daylight to penetrate the building through a number of these garden courtyards, so you have daylight both on the perimeter and on the inside. Then, just thinking about how to design a fixture. We were looking at reducing material quantities. So you saw in those pictures of the fixture that it's a very narrow profile. The housing is actually quite small. The lens sticks out beyond it. We could reduce the amount of material that went into it and the amount of packaging that we needed for it. It's an adaptable system where we can swap out the parts from different fixtures. It's easy to replace parts because they are all disassemblable. And it offers flexibility in that we can adapt those lenses and the looks of the scenes that it creates to multiple different uses. And those atmospheres, we call them, contribute to what we see as a high-quality lighting design, a design that people want to keep with them. So I want to wrap up then by saying, how do we push this forward? How do we use this idea of these principles in more and more projects? And one thing that we've looked at doing internally, and we're interested in trying to work with DLC to put into a broader use, is this idea of tools that we can use to find the right light for each situation. We call this Luminaire Broker. I would think of it as like a dating website for lighting designers and manufacturers. So you can go in and say what it is that you want. Do you want so many lumens, such and such wattage, this form factor, and then get back information on different fixtures that are out there that you might consider. And one of the things we can do now is to say that we want to limit ourselves to looking at manufacturers who have provided an EPD. Or at least limit ourselves to fixtures where we know that they were manufactured within a certain radius of our project, so that we have some elements of the carbon footprint that we want to control from the outset. And we believe that by making this a part of our decision-making process, we can move the industry and encourage manufacturers to know that if they're providing an EPD, that makes their products more desirable to us and to the end user.